stats, though, this is the homework from page 131, 132, and then we'll go into the lecture. All right, so the first couple, we want to kind of draw, what something like 0.95 would look like. That's going to be pretty close to a straight line. Okay, number two, if we had a negative 0.2, so that's going to be a negative slope, but kind of scattered. And there's no perfection to these. Number three, r equals negative 0.5. Again, that's going to be similar to what number two looks like, but a little bit tighter. Maybe a couple that are out of spot. Number four, r equals 1. So that's exactly a straight line of our data. 5, 6, and 7, you're just having data all over the place. Okay, however you want to make that. Number 8, it says interpreting context. So if we had a correlation between GPA and ACT of 0.4, so this is a weak, it's kind of a weak positive data. Number 9, correlation between carbohydrates and cancer. So this is all over the place. You can't really see a pattern to it. Okay, number 10, I'm going to find the correlation, so we're going to jump onto Desmos. All right, so we're going to enter this data on problem number 10 in Desmos. So let's take a look at it. So first thing we're going to do, we're going to hit the plus button. We want a table now because we have two SIPR. So I have 4 and 8, 10, 5, 7, 5, 8, 3, 5, 4, 6, 5, 3, 7, 6 and 6, 9 and 3. If you want to see all your data, hit the plus button and it's going to show your data. So it looks like it has got a negative value. So I'm going to go, because my y value is y1, so you go y1, it automatically subtitles it. Shift of the, find tilde, that's under the alpha on yours, mx1 plus b. Okay, so if you take a look at that, and that, that's y equals mx plus b, that's just your slope-intercept form. So you take a look at it, you look at your R value. Your R value is negative 0.68, roughly negative 0.69. So that's our correlation. We look at the R value, not at the R squared. On page 132, we're taking a look at it. We have the scatter plot that's there. What information is missing from the scatter plot that might provide a better understanding of the data? Well, we have education as the X value and income as the Y value. I'd say those are in units, and those are probably levels of grade. So it looks like the more education you have, the more money you would make, and we all have the person that we know that's done that. So estimate the correlation. The correlation is going to be a positive correlation. It's probably between 0.5 and 0.7, somewhere in there. Interpret the correlation. The more money you make, the more education you had. But it's relatively, it's a moderate, it's not really weak, but it's not really strong either. And then education and income appear to be positively associated. Explain what is meant. The more money you make, the more education you would have had. Using the y direction over the x direction, your slope. One theory might be presented based on this data. The more education you receive, the more income you'll make in life. Does a scatter plot prove this theory? Why or why not? Well, because our R value is probably between 0.5 and 0.7, it doesn't necessarily indicate that. I mean, it shows a trend, but there's not a guarantee on it. And that's what we have on there. Okay, so we're going to go to 2-3. Which is going to be on the page, I'm sorry. All right, correlation and causation. So the number one most important thing, so we're on page 34, in all of statistics, is correlation never by itself implies causation. Okay, so highlight that. It's already bolded on your thing, but maybe highlight it, earmark it, write that down. Okay, the correlation R is an important indicator of the relationship between two variables. Okay, again, R is how well does our data fit to the line of best fit. At least the idea of plausible to predict one outcome from another. However, association of causation are two different concepts. Correlation never by itself implies causation. Okay, so we said that. In 2003, a study by Harvard Perspective study of fruit and vegetable intake and risk of type 2 diabetes in women found negative correlation. That is, the higher consumption of fruits and vegetables is associated some way with the lower risk of type 2 diabetes. This study can be found easily online. Natural follow-up for this is people eat more fruits and vegetables, will their risk of type 2 diabetes go down? In other words, does the increase of fruits and vegetables directly cause the lower risk of type 2 diabetes? The problem with variables is easily associated with many other variables. Those variables might or might not be true cause. One true causes it to get complicated, type 2 diabetes. It's plausible that people who eat more fruits and vegetables exercise more. That is something that could take place. Is it plausible people eat more fruits and vegetables, consume more fiber? That is also possible. Is it plausible that people who eat more fruits and vegetables also consume more vitamins like iron and potassium? And that's also possible. So there's all kinds of things that could apply into that, not just saying that the fruits and vegetables make type 2 diabetes go down. So the variables might be linked to a decreased risk of type 2 diabetes. Which one is the cause? Is there a way to answer the question based on the scatter plot and correlation? We can discover relationships and associations with scatter plots, but not cause. The question remains, how do we establish cause? Well, here in 2014, bottom of page 34, study by University of Minnesota examining the impact of later high school start times in health and academic performance in high school students. Multi-site study research found positive association between students who started school later in the morning in their academic performance and general health. Okay, our district did that. We changed our high school start time. Okay, did we necessarily see better scores as a result? The general case cause and effect relationship will later times actually improve student health and academic performance. You can't conclude this based on the data collection and correlation, but there's a strong tendency that people jump to cause and effect conclusions anyway. It is a risk if changing start times does result in improved academic performance. That's terrific. If it doesn't, or the change, whether detrimental changes along the way, then this would be a wasted effort. In this particular study, they concluded some biological evidence regarding how sleep patterns affect energy, attention span, and the ability to acquire new academic material that adds some weight to this theory. Yet it remains an unproven theory in need for further study. So correlation is great for creating theories, but it does not prove them. Again, correlation is great for creating theories, but you're not proving it with correlation. Middle of page 35, between 1924 and 32, factory known as Hawthorne conducted studies to see if improving work environment improved productivity of their employees. The company experimented with the lighting and cleanliness of the factory, relocating workstations and made changes while researchers observed. Okay, so that's the big key. So they were showing that all of this was taking place. You had better working conditions, but the workers knew that they were being observed the entire time. So were people working harder because they were being observed by their bosses, or were they working harder truly because of um, the information? So, if you increased your working space, if you were being watched a lot more, I mean, think about it. If you were being watched while you're doing a task nonstop, wouldn't you be doing better at your task? Did it really necessarily mean that you had a better life situation? So this is called the Hawthorne effect. And the Hawthorne effect basically is when you are being watched and they are gathering data when you're being watched. You're being watched, you know they're being watched, and you go with that. Um, page 36, this is a little bit longer unit. It says scatterplot shows strong connection between fat intake and cancer rates worldwide. Consider the follow-up analysis of scatterplot. So the diagram on the previous page, fat causes cancer, but the evidence is quite weak because things aren't equal. For example, countries with a lot of fat in their diet also had a lot of sugar. A plot of colon cancer rates against sugar consumption would also, just like figure 8, if you look at your thing, figure 8 was there. It's showing all kinds of things, but there's all these other factors that are going into it. So you can't just conclude, sugar intake is going to increase cancer. Rating relationships between two variables, middle of page 36. Journalists write about research studies. They often attempt to explain the study. Research must be careful not to assume causation, ideally. Also write about the relationship between variables. So example 1, let's assume that a research study found that strong negative relationship between consumption of vegetables and cholesterol level. Okay, a poor way is research study found consuming vegetables is a good way to lower cholesterol. A better way is a research study found that consuming vegetables might be a good way to lower cholesterol. So the word might being in there, it might show something there. And then the best way to say it is a study found that high amounts of vegetable consumption is linked in some way to lower cholesterol levels. More research is needed to understand the nature of this link. Of course, the best way, it's kind of boring, actually reflects what is being understood in the study, vegetable consumption. Okay, so your homework, this was 2-3. So 2-3 is going to be on page 133, 134. Okay, so take a look at that. I mean, there's kind of have some fun with it because there's all kinds of good arguments you can have in place on there. Have a nice day.